This will be a fun stress test for my 4-year-old MacBook Pro. This will be a fun stress test for my 4-year-old MacBook Pro. Cool. I'm going to mute that. All right. Welcome. Who do we got? I see a Chad Leposki, and I see Volker. Hey, Volker, shout out. A few other people.
Jacob, Eugene, Dennis, Daniel. And there was one guy getting up at 4 a.m. to join us.
Oh my gosh.
Wow.
That's his time zone.
That is what we call commitment. That's the Kristy factor. I I can't talk. I still see people filing in, so we'll just give it a minute or two, and then we'll get underway. Scott, tell us a joke.
Oh, yeah. So let's see. My 4-year-old daughter just told me a joke the other day. Let's see, what was it about? It was a real groaner. Why did the cookie go to the doctor?
Why?
He was feeling crummy.
Your daughter's like repeating dad jokes back to you. I love that.
Yeah, she didn't get them from me, that's for sure.
That's awesome. Okay, guys. Well, people are still joining. That's okay. We're streaming live to YouTube for the first time, so that's exciting. So let's get started. First of all, welcome everybody to the Blockchain and Crypto Mining Association webinar. My name is JP Latour. I'm the Southwest Director at BCMA, which, if you're unfamiliar, is the world's largest nonprofit association for crypto miners. And here with me, I have my co-host, Scott Offord, also with the BCMA.
Hey, everybody.
And guys, we have a very special guest. We're joined by Kristy-Leigh Minehan. Did I say that right, Kristy?
Yep.
Kristy-Leigh Minehan, CTO of Core Scientific. They are a leader in infrastructure for blockchain and artificial intelligence. Kristy is better known in the community as Oh God, a Girl. Kristy has been an integral part of the blockchain ecosystem since its early beginnings, working as a consultant and advisor to multiple Fortune 500 companies on blockchain business strategies and solutions. Her work in the fields of software development, semiconductor engineering, hardware acceleration, and system scalability have changed the landscape of distributed computing and proof of work. So we're pleased to have her here with us. And whew, that was an epic intro. So Kristy, welcome. Thank you for being here with us. How are you?
I'm doing good. Thank you so much for having me, guys.
Thank you for being here. So we're going to be talking about the future of mining, ASIC, GPU, and FPGA development a little bit, and we'll get to know Kristy more. So with that, we're going to kick things off. We're going to be doing an interview format today, guys. At the end, we'll save some time for questions from all of you. So feel free to ask your questions in the chat by clicking on the Q&A button at the bottom, and we'll have Kristy try to answer those at the end. Does that seem fair?
Let's do it. Sounds good.
So, Kristy, how did you first get involved in cryptocurrency?
Oh, straight to the chase. So I first got involved with blockchain in about 2008. So the white paper was dropped in one of the IRC chat rooms I frequented. And all of my friends at the time were super excited, and they were like, oh my God, this is mind-blowing technology. And I had no idea what that white paper was about. You know, I read it and I was like, I don't understand any of this. But I tried to act excited because all my friends were super excited. Cut to 2009 and the first software drops, the first iteration of the Bitcoin software. I tried out, you know, it's kind of cool. The mining portion became very intriguing to me because it wasn't about what kind of money it could make. It was very much like a video game. You were just chasing higher hash rate, higher numbers, and I would compete with my friends, specifically in that chat group. And eventually one of the guys started bragging about how he'd reached this insane number, and it got all of us jealous. And we asked, how did you do that? What settings did you use? How did you overclock your CPU? And he was like, no, I rewrote the software. So I was like, oh, okay, that's the thing. Maybe I should try and do that as well. Mostly because I was sick of the dudes bragging. So I went in, and for about a month, I tried to figure out how I could optimize this CPU-based code. And you have to understand, back then, I mean, this was almost 10 years ago. I had no understanding of what I was doing. So it was a lot of trial and error, which is not the way you should ever program. It was a lot of reverse engineering, figuring out, hey, does this work, Stack Overflow, etc. And eventually, about 4 weeks later, it compiled. My program compiled, and I was super excited. And I was like, wow, hey, I actually did something. And hey, it made the hash rate a little bit better. Wow, that's pretty cool. What I ended up doing was just compressing 4 threads into one. And that gave it like a minor speed up. It was like a 1% optimization, but it was pretty impressive. And then I thought, okay, I'm onto something here. Let's do that again. And so that really bootstrapped my career into what I call optimizations, which is continually looking at software and figuring out how can you improve it so that it saturates the hardware in a more efficient way, whether it's CPUs, GPUs, FPGAs, or even ASIC firmware. And so in 2010, I got my first paycheck in Bitcoin. And since then, I've pretty much built a career off writing mining software.
That's awesome.
So from day one, you're basically involved in optimization, essentially. That's kind of what drew you to mining, was trying to min-max, right? Trying to squeeze out every little last bit of efficiency out of whatever system you're working with.
Yeah, so it was always, I was always focused on the software side. In 2013, I contracted for a few companies. They were building out FPGAs for Bitcoin mining, and then eventually FPGAs for Litecoin mining. So I contracted with a few of these, helped design a bit of the hardware, but it wasn't until 2014 that I actually got interested in ASICs and started working from a hardware level. And my fascination to mining has really always just been a natural progression. I mean, you kind of want to understand how your users are using your software, what your customers are doing with this software so you can better build products. So it was just a deep fascination of how do I go and improve the efficiency of this one GPU card to 30%? And how do I wow people doing that? And in about, I think it was 2016, Genesis Mining picked me up. Might have been a year before, might have been 2015, but sometime around there, Genesis Mining picked me up. And they brought an Ethereum kernel from me, optimized Ethereum kernel. And that kind of bootstrapped my career into proper corporate / professional world. And working with Genesis Mining, I have to say, was pretty awesome. I mean, that was I'd seen other people do deployments at scale. I'd seen other people do mining at scale, but no company had been focused on the customer like Genesis Mining was. So getting to work with them, seeing how they ran a global operation, that was a huge game changer. And, then we went off into China. We built our own data centers. We built our own hardware at scale, which was pretty fun. I got to learn the entire supply chain and the entire manufacturing life cycle for a GPU card, all the way down to how do you go and pick the individual components? What choice do you make on those components? How do you go build the PCB? All the way up to how do you go and actually source the memory, and how is it bundled with the GPU ASICs? And then from that point, how do you go write your own firmware for that GPU card to get an optimized performance? So that was a huge learning curve, and it was a lot of fun.
So Kristy, if it were up to you, what would it be? FPGA, GPU, or ASIC? If you can only do one for the rest of your life.
If you could only do one, is the ASIC locked into one coin, or do I get to just say ASIC for all the different coins?
No comment.
I mean, If I was an investor, I'd invest in FPGAs or GPUs just for the versatility.
Nice.
But I mean, from a hardware designer's perspective, ASICs are just a lot more fun. ASICs provide you an entirely new. So most people don't realize that there's a reason that Intel right now is failing to do SHA-256 ASICs. It's because when you're developing or designing a SHA-256D ASIC, you're operating on the edge of the process node. Most GPU cores are actually on the center of the process node. Because you're operating on the very edge, your yield isn't that great, and also your performance isn't that great. It really takes a specialized process to catch up with that. So Intel's been trying for SHA-256D ASICs for, I think, about a year and a half now. And they continuously, their process node specifically misses a lot of the performance that that companies like MicroBT, companies, how do you shave off Bitmain, companies like Canaan need. And it's going to take them at least 10 years of catching up. So there's so much specialization that goes into SHA-256D. But most people wouldn't realize that because they just think, hey, it's a really simple algorithm. And that's how a software engineer usually thinks, right? But on the hardware layer, it's a lot of beauty in figuring out how
the physical die itself, the package, right?
Yeah, well, even TSMC, if TSMC's engineers tried to replicate, they'd often fail. I mean, how ASICs are designed now is very much a marriage between what we call analog designers. These are people that understand silicon really intimately, and they work on just optimizing the gates and the routing and the placement really on the logic level. Then digital designers who are more algorithm, C, firmware, what we call floor planning. It's a marriage of those two working hand in hand with TSMC. But it's very much like a table. If you remove one of the legs, nothing works. So Intel has tried to sort of become vertically integrated in the SHA-256D space, and they're finding that they can't really compete with MicroBT's insane performance. They can't compete with Bitmain's performance. I think they will one day eventually, but they're going to have to play 10 years worth of catch up in this space.
That's fascinating. Speaking of all of this, I'm going to jump around here a little bit, but could you kind of walk us through, help demystify this process of building hardware, doing the R&D, designing a chip, and then everything that comes, that sort of precedes bringing it to market, right? How do these ASIC manufacturers like Bitmain, for example, actually go about designing a 7-nanometer chip and then building a miner around it?
Mm-hmm. I mean, first, it all starts with what we call the golden code. And this kind of format is pretty standard for any coin. So your golden code is your optimized GPU algorithm. Your golden code can be written by the ASIC company themselves or outsourced, which is a lot of what the work I've done. So your golden code becomes your standard, and then you translate that to a HDL-like language so that you can optimize and emulate performance on an FPGA. So after you've done your FPGA code, then it comes time to actually doing an integration on what would be your simulations, whether it's with Cadence or Synopsys, which are basically giant clusters of FPGAs. I don't know how to accurately explain them, but they look like giant fridges, and inside it's just a bunch of really heavily high density FPGA boards. And these simulate the performance of an ASIC. And then there's various iterations here. There's iterations of lots of simulation, iterations of how do we take this algorithm, translate it into the silicon layer? What exact gates are we using? How are we optimizing those gates? All your different logic gates you take from your FPGA or your HDL language, and translating that onto silicon. And then it's about 6 months to a year of testing and tuning and tweaking. And all sorts of little tricks and tricks come about from that. Simulations will show you something and you'll realize, hey, if I tweak this logic gate here, or I move this access here, I'll get a 1% speed up in the simulation. One of the big difficulties is the smaller you go in your process node, the more difficult it becomes to simulate. When you start working below about, I think it's about 10 nanometer, there are a lot of simulations and after effects that we don't really understand. That is to say, we don't understand why this happens. And this is because once you're dealing at that level, you're really dealing in the quantum world, and it will only get worse.
Electrons just kind of flying everywhere.
Exactly. So what you have to do once you get down to below 10 nanometer is you have to do what's known as an MPW, or multi-project wafer, which is basically where you share the cost of a wafer with 100 other companies or so, and you tape out and you put your design on an actual wafer to verify the performance. This is the only way you can be sure in your results. So MicroBT does a ton of MPWs, so does Bitmain. So when you probably in 2018, there was all that news flying around about Bitmain's failed tape outs. Well, it actually wasn't failed tape outs. They were MPWs, multi-project wafers. This is a normal process that pretty much any ASIC company should do if they want to build a standard certified product. And then some companies skip them, like InnoSilicon skips MPWs. So each company has their own, way of going about this. Hopefully that answered some of the questions.
So what would be a reason for skipping that part?
Cost and time to market. So you have a first mover advantage if you bypass an MPW, and usually you want to skip an MPW if you're developing for an altcoin where first mover advantage is very important. So this would be something like Grin. Grin is a perfect candidate for first mover advantage. However, when you're talking about SHA-256D, this is a very established market. You want to ensure you have the best possible performance because you're going to invest a lot of capex into wafers, and you want to make sure you've got a very competitive performance that people will buy.
Yeah. So I have a question then that kind of leads into that. So as far as the last year or year and a half or so, it seems like there's been a lot of weak performance from new chips that are coming out, 10 nanometer, whatever it might be. I guess, for example, with Bitmain, they came out with their first round of 7 nanometer. Now they're coming out with their second round. What would you say are some of the biggest reasons why their first round didn't really perform as well as people had thought it would?
It could have been anything so it's really cool when you break down a SHA-256D chip. If you've ever torn apart a S9 hash board, and I wish I had a spare hash board floating around, but if you've ever torn apart one, it's a bunch of little chips, right? Well, inside each of those little chips is actually a really round core with a bunch of other little chips inside. Getting the latency, the logic, the frequency between all those little cores inside of the actual SHA-256D chip is incredibly hard. It takes a few full tape outs to get right. Bitmain most likely taped out originally, and they'd already invested the capex in these wafers, in these engineering samples. It wasn't what they hoped for. It wasn't their simulation target. And they realized, okay, well, we've already taped them out. We might as well sell them. So it's their first gen. Go ahead.
Oh yeah, no. So I was just going to say, I heard that if a miner all of a sudden becomes available on the market that nobody really knew about 4 months ago, there might be a question as to if that's actually something that has already been in use by the manufacturer, or if it's I guess what I'm wondering is how does that work as far as at least like with the SHA-256 algorithm. Would you say companies like Bitmain have already been using this stuff in private or on their own farms, and then all of a sudden, say, hey, rest of the world, we're coming out with something new, when actually it's not really that new.
Yeah. So unfortunately, when you're not a public company, this is commonplace. Historically, Bitmain did used to mine with their equipment. This was back in 2014, 2015, 2016, and 17. So what they would do is they would build a lot of machines for their own. They would mine with them, and then they would sell out that equipment either through their cloud mining, which has spanned, it used to be like something like Hashnest. Now it's spanned across 3 or 4 other companies. BitDeer is one of them, etc. So they used to do that for their equipment, and they'd quickly recoup the capex. The other piece is often with an altcoin, you would quickly deploy it in your own farm and mine with it for 5 to 6 months and then release it. This is a common effect, and it's not exclusive to Bitmain. This is just what happens because manufacturers have to de-risk their capex investment somehow. There is no guarantee of sales in a crypto mining market.
And so when they're using them in their own farms, they're not necessarily then selling those miners as new miners, right? They might be selling them later in the future as used miners in the secondary market.
Unfortunately, no, not the case. Now, Bitmain stopped it in the last year. They have cleaned up their act quite a bit, but historically, it was sold as brand new. A great example is the first generation Zcash miners. I mean, those were sold as brand new, and they showed up on people's doors with tons of dust and dead chips, and there had been definite use. And that's what I mean by de-risking the capex investment. They need to guarantee a way that they can get at least half of the initial wafer cost back. It's very important to a manufacturer. Hardware is an incredibly risky business. Most people think cryptocurrency has taught people that hardware is this billion-dollar business where you can make tons of money. Well, actually, it's a very cutthroat business where if you make one wrong move, you're completely bankrupt. Right. And that's where we're seeing the ecosystem trend towards. The other way of how we used to handle cryptocurrency sales, hardware sales, most manufacturers sell hardware at cost plus markup. So they're very transparent with their costs, and then they just tack on a standard 30 to 40% markup. And so you always can help a manufacturer optimize for the cost, and it will benefit you both. It's a very symbiotic relationship actually between large scale customer and company. In Bitmain's case, what often was done is they would price according to ROI. They'd look at how fast you could ROI back. And if it was, say, 9 months, they'd look at what's on the Chinese used markets. They'd see some trader flipping it for a much higher price, and they would adjust their prices accordingly. So there's never been cost plus markup before in crypto mining. It's always been point to break even. That's because miners generally treat their equipment on a much shorter depreciation cycle. Most hardware is depreciated at a rate of 2 to 3 years, whereas when we think about ASICs, we depreciate it over 9 months. So not only is selling to miners a different market, but they were constantly competing with the traders in China. I mean, I'm sure, as you know, Scott, the used hardware market in China is insane. It's a market maker. And so they were always looking at that, and they were like, well, hang on, the trader's making $30 more per machine than I am. I need to raise my price. Unfortunately, what ended up happening was a market was created where people were instead competing on price rather than innovation or IP. So for 2016 and 2017, people got very lazy. They got very fat on a lot of money. And then 2018 hit, the crypto markets crashed. And then we realized, Bitmain, I think, quickly realized, hey, we actually have to start innovating again. We have to clean up our act a little bit because the market has changed.
So how much is too much, though, when you say how they base their price? If Bitcoin went to $200,000, next week, would Bitmain start selling these things for $10,000?
Yes. And that's the wrong way to go about it. How it needs to be done is the same as all hardware is sold: cost plus markup.
Mm-hmm.
Unfortunately, oh, go ahead.
No, go ahead. Sorry, finish your thought.
Unfortunately, hardware manufacturers in cryptocurrency are not honest with their cost. So you get a lot of manufacturers, particularly today, that simply say, hey, this is our real cost. We're only taking a 10% markup. And by the way, our competitor is selling well below their cost and they're going bankrupt. There's no transparency in this industry about what the cost of making a machine actually is.
The cost, and as well the number of miners that the manufacturer is producing. There are some manufacturers that like to keep that very transparent and open, but it almost seems that if no other manufacturer is doing that, what's the benefit? What's the use in disclosing that information, right?
Correct. Well, there's a great benefit. One, it would bring in more institutional money if we started to standardize. I think people fail to realize that there's no new money coming into Bitcoin right now with the way the market acts and the way the market is set up. The only people to sell miners to are already miners who have older equipment. No one's really looking to invest in scale in Bitcoin mining right now. So how do you attract institutional money? How do you attract new money? Well, you start with standardizations for one. Standards are important. You start with, a trusted infrastructure company. I might know of one. And you start with transparency. We have to aspire to the same sort of transparency that other Fortune 500 companies already operate on. That means you have to be accurate with your bill of materials. You have to be accurate with the number of units you've sold. You have to accurately explain how much equipment you've put out into the market. You can't hoard that information. You can't sit in a data silo.
I think Kristy, you've touched on a couple of things that I've heard talked about a lot in the community, right? Beginning to be more transparent about publishing numbers in terms of batch size and things like that. Not to call anybody out specifically, but Bitmain is around 80% of the market, and they seem to have gotten very good about sort of perfectly price discriminating based on block reward size and ROI, as you mentioned, rather than operating on this cost plus model. But this kind of brings up another subject, which is we've seen this pivot away from 16 nanometer, right? The old sort of technology that has been in these miners for the last 3 or so years towards a 7 nanometer generation miner that everybody's coming out with. It's been interesting to see the improvement in the efficiency, right? Averaging somewhere around 50 to 60% currently from the 16 nanometer down to some of the more competitive 7 nanometer chips that we're seeing. But even just Bitmain, as we talked about already, has, they came out with the S15, right? And then they came out with the S17 recently. And just between those two models, they're both using different chips, but they're both based on a 7 nanometer node process. We saw significant improvement between those two models. So this begs the question, how much more efficiency is left to be squeezed out of a 7 nanometer node process?
For SHA-256D, there's probably around, so if I recall, Bitmain's doing theirs on TSMC. So they probably have around a 10 to 15% optimization to go. If you do a teardown of their chip, it's actually quite tightly packed. Now their competitors, MicroBT, are working on, I think they're also either working on TSMC or maybe they're working on Samsung. So if they're working on Samsung's 8 nanometer, there's a huge efficiency gap that they can still claim.
I believe it's 12 nanometer.
12 nanometer. Oh, that's even better. So they, right now at their performance, which I believe, they advertised on WeChat that they're hitting 72 terahash right now at 56 watts, which is an insane performance.
It might be more like 70 by the time they're all done, I think.
Yeah, but that's really good. So they'll probably be able to hit around 15 to 20% more on 12 nanometer Samsung. And then if they go to 8 nanometer, they're going to get around around about 40 to anywhere from actually 30 to 35 watts per chip, which would be really impressive.
That's really interesting. Kristy, when you say like they find these efficiencies, right, squeezing an extra 10 to 15% out of an existing node process, like 12 nanometer or 8 nanometer or whatever, does that require a hardware adjustment, or are you talking about a firmware adjustment, or where
Silicon.
are they finding that?
It's silicon. It's the job of the analog designers, and a lot of it will come due to hand routing. Think of this is probably going to be a terrible explanation, and someone who's an expert who's listening is going to shoot me for this, but think of ASIC design kind of like Lego blocks. And when you're thinking about chip design, and silicon design, it's kind of like Lego blocks. There's a reason we call it floor planning. So what you're trying to do is connect all of these Lego blocks in the most efficient format possible so that it saves space, which will consume less power, and so that electricity will route through it much, much faster. So you'll get a much better frequency. And so a lot of the optimizations that we talk about are actually hand tuning, either custom placement of cells, custom routing, all of this fine-tuned detail, especially figuring out, hey, where can I save on logic gates? Where can I put a NAND instead of a ZAND here, etc. So all of that work is, it's very mind-numbing. It takes someone of a very particular mindset to just sit there and just stare at basically logic gates and figure out how to combine them. But that is how you get the ultimate kind of performance. And so Intel, NVIDIA, AMD, they have teams of 100,000 engineers that do this all day, every day. And same with companies like MicroBT. MicroBT has a team of 30 engineers that just work on this kind of level 24/7.
So you're talking a lot about corporations and their contributions to the hardware. But what about the open source community and how that might play into things? I know obviously that it's very difficult for open source community to build hardware per se that's going to be sold on a mass scale, but things like Conclavus, I think I said that right. CK, he's contributed heavily to open source software for the mining industry. But yeah, I'd love to hear your take on the whole open source side of things and how that's already contributed to this, and how corporations are using that either properly or improperly.
Yep. So, I mean, the first thing to note is, coming back from my tour of China, there's a common theme that I figured I'd share with everyone. Manufacturers are deciding to go vertically integrated. What this means is that they're not only integrating their PSUs so that you will no longer be able to use your own white labeled solutions. You'll have to RMA the entire unit. So everything's integrated with bus bars, but they're locking down their hardware. They're using their own version of which truly is just CG Miner with OpenWRT and Lucy or Leti, all bundled up, developing on top of that. And all of it is closed source and actually tied to the fingerprint of the machine, what we call the ASIC ID. They're going through this route, and then they're saying the only way that you're going to be able to monitor, manage, or control your machine is with their tools. Case in point with Bitmain, they have, I believe it's called AP tool, which is like Antpool tool, that allows you to, optimize or manage your machines at scale. So they're trying to get you locked into their ecosystem, which I'm a firm believer that if you buy hardware, you have access to that hardware. You should not be told how you can use that hardware, what you can run on it, and you should not be locked into the ecosystem of the manufacturer.
So is it sort of like the difference between Apple and Google in that case? Like, some people really love Google because you could do so much with it. Some people really like Apple just because it's very simple and clean. Is that how it is kind of in this market?
I mean, it's more like you're locked in between Android and a shitty Chinese knockoff. Because here's the other problem: the people that are building the tools at Bitmain have no understanding of product, especially in the Western market. If you look at the UI and the UX of some of these tools, like average Joe isn't going to know how the hell to use those tools.
Mm-hmm.
Nothing is really made for the standard consumer at scale. I mean, if you're a developer and you want to start getting interested in your hardware at Apple, you can actually go under their NDA program and you can get access to a lot of that documentation. People just, you can't do that with Bitmain. It doesn't matter how many NDAs you're under. It doesn't matter how many ASICs you're purchasing right now. They're keeping a lock and key on their software. So what this is doing is encouraging a ton of development around open source software. You have the asicfreeware.io guys. You have Brains OS. We have ASIC Drip, I think is another one. All of these really talented developers that are starting to reverse engineer and just break in and make their own changes. Now, the other piece to all of this is Bitmain is just, most people don't realize, but CG Miner is an industry standard. That means every single ASIC manufacturer is using some version of CG Miner.
Mm-hmm.
Unfortunately, there's no standardization over what version they use. So it's a complete monstrosity to manage equipment at scale with all these different variations of CG Miner. That isn't necessarily a good thing. I mean, I can guarantee you CK isn't getting any money from all of this, all of the work he has done and what the companies are profiting off. So when we actually started at Core, one of my first initiatives was, after having worked at Genesis Mining and figuring out how much of a pain it was to manage this equipment at scale, we decided we were going to go and invest in the talent and actually build our own firmware. Something that we could standardize across all of our deployments, so that we wouldn't be locked into this ecosystem of the manufacturers. CG Miner was fantastic for its time, but it was developed, 8 years ago. We need way more features specifically at Core Scientific than CG Miner can provide, and we need a standardized API across all of our equipment. So that's where we started investing our time and our talent first.
Mm-hmm.
And it's been very successful. We've had a lot of manufacturers actually ask us, can they license the firmware and use it for their machines instead of, standard CG Miner, etc. And so we're not sure if we'll ever go down that route. It's something that, we're open to exploring. But
yeah, and you also shared recently, I think on Telegram, another manufacturer that made things open source, and that seemed really interesting.
Yeah, so Canaan has taken some fantastic steps on this front. I'm really supportive of Canaan lately because what they're doing is, so I think it was some of the Canaan team left Canaan and went off to start their own thing. And from that came eHash. eHash.org is actually the 851, Avalon 851 schematics, all completely open sourced. It's the BOM, it's the chip design, it's the FPGA, it's the source code, it's the 3D models, it's everything. You could take all of that and go to pretty much any manufacturer in China, or any, to TSMC if you really had the cash, and you could build your own chips and you could build your own ASIC. Canaan is more embracing this open source side. So they're handling it this way because they believe that more pairs of eyes are better for them producing better software. More pairs of eyes will help them create a better product. And also because from that becomes a lot more security. And it will also reduce their OpEx themselves because, we have a talented community of developers in cryptocurrency that would love to just, tinker with this firmware on their own in their spare time and contribute things just for the fun of it.
Right.
So Canaan is embracing that open source ecosystem. Now, there are going to be pieces that they can't embrace for various reasons, but they're doing their absolute best, which I'm really supportive of.
That's
fascinating. I guess one last part to that. How would somebody that's interested in open source software, how would they get involved with all that? Because it's so deep, and a lot of it is very geared around intellectual property.
Mm-hmm.
and it's very hardware specific. How would a programmer get into helping with the open source projects?
So usually if you're a programmer, the best place you can start is with what we call the firmware, which is how work is fed from the pool to the various chips. You can't open source SHA-256 cores per se, because it uses libraries from TSMC, Global Foundries, or Samsung. They're very protective of those cell libraries. They would never standardize or open those up to the world. It is an IP thing at that point. And you have to understand that's their revenue driver, so why not? So the next step you can go is in standardizing things like the BOM. One of the initiatives I'm working on right now, which I hope that I can talk about in a few months, is actually working with all of these manufacturers to provide transparency around the real BOM cost and bring all of that onto the blockchain, which I think is going to be game changing for this space.
Wow.
It's very cool.
It's very, very exciting. I'm really excited to be able to talk about that. I think we're going to do the announcement at the end of May, but I'm not sure. If it's not ready, we won't announce it. But so the other piece is for companies that are embracing open source software like Canaan, figure out how you can chip in and help them basically how can you help them contribute to their sales pipeline? Because these hardware companies that are embracing open source, I can tell you they're not going to be winning the battle against Bitmain. So they need to rely on the community to help them. We're all in this blockchain thing together.
So we've got a ton more questions that I'd really love to get to. But just a quick follow-up on something that you said, Kristy. You mentioned that you guys at Core Scientific are developing custom firmware and sort of providing a unified API layer to interface with the machines that you guys are running. I don't know what you can share, but can you shed a little bit more light into some of that hardware and how you guys make those decisions, even at a kind of superficial high level, in terms of how should a miner that's interested in achieving the best ROI, how should they be making purchasing decisions, right? Because this is something that, I've looked up personally. It's something that a lot of people that I've talked to, everybody kind of adopts a different approach. So how do you guys look at it? And if you can share, what's some of the hardware that you guys are investing in?
Well, I mean, the first thing to understand is Core Scientific is we're not a mining play. We have some of our own equipment, which we really use to teach us how to be a better hosting provider. But we don't gamble in mining and we don't invest in that, which surprises a lot of people. They're like, how can you have all this money and be a blockchain company if you're not mining? The second thing is if you're looking, it depends on the hardware first. For SHA-256 ASICs, or for any ASICs in general, it's about your terahash, or your measurement of hash per watt per USD. Most manufacturers really like to advertise their terahash per watt, but if it's 51 USD per terahash, I'm not going to buy that. No way in hell. So you have to make sure you have that third metric of price. Miners do care about break-even time. This is how we ingest data when we're making our purchasing decisions. So everything when you're thinking about what should you invest in, it needs to be around that metric. The third metric is figuring out, hey, is my equipment very exotic? Am I going to be able to repair it if it dies? Especially if it has a really long ROI cycle, or is it more standard? Is it in a standard Antminer box, even if it's not an Antminer? Does it have standard fans that I can easily find? Does it use a standard PSU? And then for FPGAs, you want to ensure that you're buying equipment that already has a very healthy developer ecosystem. Unless you're planning on writing your own bit streams for FPGAs, you don't want to invest in them. So this is companies like BlackMiner, which I think they go by Hash Altcoin. Actually, they came out with the F1 and the F1 Plus, which basically look like ASICs, but they're actually FPGA units, and they have an offering of around 20 plus coins. So really good investment there. And also a gentleman called Whitefire is coming out with his own $300 ASIC boards, which mimic a GPU card. So good investment there. And then for GPUs, Really, it's that same criteria of USD per unit of hash per unit of measurement. But then you also want to be thinking long term. How does my GPU card have resale value? If you ever want to get out of mining, or if you ever want to diversify into selling your compute workloads to AI or rendering, and there are applications today specifically built on the blockchain that enable you to do that, you want to ensure you have a quite beefy GPU. This means don't invest into, a 1050 Ti unless you can break even in 3 months. So generally the ROI cycle that I personally try to target is 9 months for GPUs, 6 months for FPGAs, and 3 months for ASICs. And ASICs will go up to four months or 5 months depending on tariffs and shipping, but that's generally the cycle I like to keep to. Yeah. And that's held steady for all of the years I've been operating in blockchain. So
if I can put you on the spot, Kristy, what specific you mentioned, I think, an FPGA company, but what specific GPU cards do you like, and what ASICs, what SHA-256 ASICs do you like right now?
Really big fan of MicroBT, their new equipment, the M20. They're doing a nice approach of open source software, even though they don't really advertise it, along with cutting edge hardware. And they have the best USD per terahash per watt ratio in the market today. The only problem is their machines are quite dense. They make for kind of an ocean nightmare. But really big fan of their equipment. And then for GPUs, I'm dealing with GPUs right now on an AI/data science level, so not quite a mining level. But any of AMD's Vega stuff is quite nice right now. So with the latest generation of Vegas, which I think is their Radeon Instinct line, they stepped up to another level. They decided, hey, we're not going to just historically AMD has just been a memory bandwidth company. They've made fantastic equipment that just trumps memory bandwidth, and that's what made it so great for Ethereum mining. But with algorithms like ProgPal that utilize more of the core, they were subpar or less efficient. So AMD fixed that with their Instinct line, where they said, we're going to invest into this HBM2 stacked on the die, and we're going to have an insane compute core with a ton of memory bandwidth. And they're doing really good there. And then for NVIDIA's line, the 1660 Ti is probably the best bang for your buck, because not only can it do low-level inference, which is really great, when you're thinking about what your mining rig is good for, it's good for hyperparameter searches, which are the building blocks of search engines like Google or like DuckDuckGo. And it's really good for training, inference training. So the 660 Ti is the best bang for your buck with that.
Mm-hmm.
That's awesome. Thank you. Scott, do you want to ask maybe a couple more questions? I think we could do like 5 to 10 more minutes, and then maybe take some questions from the audience.
Yeah. So, I mean, back to the economy, retail miners versus mega farms. We've seen a lot of consolidation there just because of the price of Bitcoin and efficiency of miners and whatnot. Do you think that there's a temporary trend, or do you think that there's a kind of a new paradigm shift taking place right now as far as who can really be doing this mining? Is it going to be the small guys still, or is it only going to be palatable for the big guys in the future?
Obviously, I'm a little biased given who I currently work for, but I think one of the biggest things I've learned is that co-location is not centralization. So most people, when they think about mining at scale, they believe that it's only obtainable to the bigger guys. Well, actually, that's kind of what co-location is designed for. It's designed so that you can take advantage of someone else's economies of scale. I think mining is going to trend towards more of this unification and partnership. We went through this in the AI industry. We're doing it in the blockchain industry now. This means that small scale miners will deploy with a company that is capable of taking their equipment and operating it at a much lower cost than they could do themselves in their own home.
So obviously
Yeah.
right now that's very important because the price of Bitcoin makes it so it's almost break even for a lot of people with their electricity rates. Like, maybe a year ago or two years ago, people can plug in a miner in their basement and they were very happy. But a couple months ago today, it's you might have to ship off your miner to a co-location center in a city or a state or country that has power that's cheap enough.
And it's not just power. That's the metric everyone's competing on right now. So when I joined Core Scientific, I realized that there is no marketing competing on power. This is why a great example is if you try and go and compete against Amazon, you can't compete on power. You can't compete on price. Amazon has very large pockets and they can just undercut you for fun. So how do you compete in blockchain and how do you make it better for the end customer? You have to invest in this value add. So when we talk about utilizing someone else's economies of scale, this is part of it. So a good co-location provider will provide you with optimizations. They will provide you with AI pieces that help, maximize which coin you should mine. They will provide you with 99+% uptime. They'll provide you with they will optimize every step of their operation so that you're getting the best possible value. They will go out and source repair components for you at a much cheaper cost than anyone else. And I think that's where we're going to see the industry trend towards this specialization. Now, companies that try to be vertically integrated will quickly find that they will not scale. So that's an important differentiation. Just because you want to specialize doesn't mean you want to become vertically integrated as well. You want to find out what is your core competency and then work with partners in the ecosystem to build up a great company. So, I mean, this is how Microsoft grew. They realized the value in their partnership ecosystem. That all needs to be brought to the blockchain mining industry now so that we all work together, we all collaborate together so that we can all share in the profits and the rewards.
There's a ton of parallels there, Kristy, between what happened with cloud computing, right? The growth of like AWS, for example, Microsoft Azure, Google Cloud, and how they've displaced the traditional data center industry. And I think that what you're basically saying is that that's going to play out in blockchain as well.
It is. And I think the important piece to understand is also cloud computing hasn't gotten rid of the data center. Actually, what it's done is it's incentivized more and more homegrown data center operators. But you can't just specialize anymore on the pricing. Cloud specializes on pricing. That's how they win all their business. So the people that are innovate, and the people that invest in IP and invest in differentiating will be the ones that stay around here today and that will win all that business.
Well, and another thing that you were saying, I think I saw on Telegram that you want to see Bitcoin kind of being in the background. And, I can't remember exactly how you phrased it, but I'm wondering if, the whole blockchain infrastructure is also going to be in the background. People are not really going to even be thinking about it very much.
Oh, that must have been from my CoinGeek Week speech. Bitcoin should be seen, not heard. I'm a big believer that blockchain technology and Bitcoin and all of the different kinds of cryptocurrencies that we use today should really just be no different to how the first database was. I mean, you ask your grandma, she doesn't know what a database is. She doesn't know how her iPhone works. She doesn't understand how her MacBook was built and how it was designed and what code runs on it. All she knows is that she can use her MacBook to surf the internet and check her email and to check Facebook. But she doesn't need to understand the underlying technology of Facebook to use it. This is where Bitcoin needs to adapt and move towards. This is where mining needs to move towards. This is where blockchain needs to move towards. And this is where we're seeing a shift now in the industry with more of a focus on product in both blockchain and AI. This isn't just exclusive to blockchain. AI has been very focused on the engineering for quite some time as well. Now we're seeing more and more people shifting towards product development, thinking about customer application, use cases, etc.
I have two questions that I'm dying to ask, and I'm hoping we can sneak in, and then maybe Scott can ask one final question. But first question is, we've been seeing a lot of news coming out of China about a ban on cryptocurrency mining. And given your relationships there, I'm wondering if you can shed a little bit of light on that and what you're hearing about that.
Sure. So I talked to all the manufacturers about it, and I wager the answers they told me in private would differ from what they would say publicly. Most of the manufacturers are a little scared because a big thing to understand for the community is in China there's the central authority, central government, and then there's all the local governments. The local governments are regional. What the central government says is often in conflict with what the local government says, and they're constantly at war with each other. But ultimately, manufacturers have to report to the central government. So when the central government says that there is a ban on Bitcoin or a ban on mining, it's actually really crippling to their business. And some manufacturers have very good relationships with governments and government officials, but at the end of the day, that doesn't always save them. So a lot of them are scared, and a lot of them are eager to diversify their business, to move to the West, to move their manufacturing operations out of China just in case. So that should the government wish to lock that down, they have some diversification. Now, the hosting providers all say the exact same thing. Oh, no worry at all. Don't worry. Government will never do that. You should just deploy more ASICs with us. Every single manufacturer I talk to says the same thing. And, it's because they want to win your business. And in truth, they're actually correct. Local governments have no problem with Bitcoin mining. Local governments encourage it because it makes the local government's CapEx and OpEx revenue seem much better than it was. And it also allows them to consume all that excess electricity. But there's going to come a point in time where the central government's going to step in, and I can guarantee you the first place they're going to go, and they're going to take away all that equipment. I went through that in 2017 with some of the companies I was working for. It was not fun to have a lot of your equipment seized by government officials and to be told, hey, if you want this,
to ban cryptocurrency mining in China outright.
So I'm not sure. I'm not sure
how you read into it as well, Kristy?
So I got the it literally got announced while I was in China, Chinese version of this. So what the Chinese directly from the report, it comes from the I think it's the NPMW MD. It's some national agency that basically looks into businesses and classifies them as illegal or legal based upon a bunch of factors. One of these factors is waste. And so Bitcoin mining, along with 420 other different businesses and business applications, were lumped in together. And they consider Bitcoin mining to be a wasteful resource that consumes a lot and generates no value. So they are going to motion to have it a banned form of business, and the public has until the 7th of May to respond to that. So it's more that it's been, and they do these updates every 5 to 6 years. So this is on a regular cycle that they revisit businesses that were up.
So it's just up for discussion is kind of what I understood. And it was like in a draft document as a proposal for discussion.
It's a draft. However, the general sentiment from a lot of the manufacturers is that the central government does want to ban it because they see that they have a big problem with the amount of money laundering and the amount of taxes they're losing out on.
So Bitcoin mining or Bitcoin in general? Bitcoin
mining. Mm-hmm. Mining is, if you want to launder money in China, you do it through Bitcoin mining. You don't go and buy Bitcoin. You invest in hardware because you can get a tax write-off, especially if it's GPUs. And I probably shouldn't be talking about this on live, but if you want to go and avoid a lot of taxes in China, you would want to go and invest in GPU hardware, and you would want to go and mine with it. And then you get a tax write-off for that, and that would be a fantastic way.
It's all between us and 500 of our best friends, Kristy. Don't worry about it.
Yes, exactly. Exactly.
We'll keep it quiet. Yeah.
I have one more question, and then Scott, I'll kick it back to you for one or two more questions, and then hopefully we can transition to the QA, because I know a couple people have asked. I see 6 questions so far. Kristy, if I may, I'm going to put you on the spot. I would love to get a price prediction from you on Bitcoin, and I leave it up to you what kind of time horizon you want to look at.
Oh, okay. My lawyers have trained me for this. Number 1, this is not financial advice. Number 2, I am not an accredited financial advisor. Number 3, these predictions could be pulled out of my ass. So take all of it with a grain of salt. But
with all of that out of the way.
Yes, I believe Bitcoin's going to hit 5.5K. It's going to then crash down, and then in probably around October, more likely November or December, we're going to see another boost. It's never going to hit 20K like it used to hit. It's probably going to stay at a nice stable 10 to 11K. So it's going to have its 5.5K peak. It's going to drop a bit. And, there's always variances when you're doing statistical prediction. It could be 5.3K, it could be 5.6K, but it will reach a peak around about there. It will drop down. It will idle for a bit, and then it will have its next spike. And that's probably going to be tied to the deployment of new S17 Pros, because remember, they're all sold out right now. So the deployment of that plus micro BT equipment, as well as watch out for a rise in price, always at consensus. Whenever consensus happens, it correlates historically with a 10 to 20% rise in cryptocurrency price for the top 30 coins, I believe it is.
That's fascinating. So mark your calendars for May, guys.
And then someone can tweet me and be like, "Oh my God, she was right," or "Oh my God, I just lost all my money." But remember, I'm not a financial advisor.
Yep. Either way.
Scott.
So one last question. And this is something I don't really know a lot of personally, because I'm more focused on the hardware side of things and marketing and sales. But POW, progressive proof of work. What can you tell us about? Yeah. What can you tell us about that?
Everything. What do you want to know about it?
Well, I hear you're a big proponent of that.
I may be a big proponent. I might have had a hand in it. Yeah. So POW, really what it's trying to do is, first and foremost, it's a lesson in how to design proof of work algorithms. And so most proof of work algorithms are designed by software developers who think they have some understanding of hardware. Instead, the correct way to design a proof of work algorithm is to go from the hardware level upwards. So POW is an example of that, and a lesson in that exercise. Number 2, proof of work is all about having an equal hardware cost versus an electricity cost. Unfortunately, when ethash was designed, it did not consume a large portion of the hardware cost. Therefore, it was a flawed proof of work algorithm that failed to meet its target hardware base, which was GPUs. Thus, you can make a very specialized, efficient ASIC for it. So what POW does is it says, I'm going to make an ASIC for ethash. It's actually going to be a GPU. The GPU is going to be the target ASIC, because in a hardware designer's brain, and in the world of hardware design, we treat everything as ASICs. And that can be hard for people to get their mind around, and especially in blockchain. But the word ASIC was used well before Bitmain came into the scene.
Right.
So
and ASIC meaning application integrated.
Yep. Yeah. And the application is fixed at the point of manufacturing. You don't go out and a GPU ASIC is actually an ASIC for compute. An FPGA is an ASIC for programmable fabric, etc., etc. So ProgPal says that, hey, I'm going to make this my target hardware base. I'm going to design an algorithm from the ground up to utilize all of that GPU card. So even if I did try to make an ASIC for it, I'd only be able to get a very minimalized gain. And if I did try and make an ASIC, it would end up actually just looking like the target hardware. That is to say, a GPU. Now, lots of ASIC experts have come out of the woodworks. The most notable one being Lindsay ASICs, which is Canaan's ex-chip team that was building an ethash ASIC. And a lot of them have tried to say, hey, this won't work. Hey, we will make a very, very high efficient ASIC for it. However, none of them are willing to engage on deep technical discussion on how this is possible. And the articles they do put out really miss how ProgPow works as a whole. So ProgPow is really a testament to, it's kind of a battle right now between GPUs and ASICs. And every ASIC manufacturer on earth is saying, hey, we'll build an ASIC for it, but they're all missing the fundamental point. It's not meant to be ASIC resistant. You cannot have ASIC resistance because everything is an ASIC. And anything that run, any kind of hardware that can run an algorithm can have an ASIC built for it. Instead, all you can do is ensure that electricity cost versus hardware cost is evened out across all applications, including FPGA, including GPU, and including ASIC. We leave CPU in a black box because one, it's very hard to optimize for all CPUs. There's so many different architectures and so many different vendors, and there's so many optimizations. And two, I don't believe that CPU mining is scalable for Ethereum. So ProgPow was specifically built for Ethereum.
So correct me if I'm wrong, Kristy, but hasn't Vitalik and a bunch of other people that are behind Ethereum, haven't they come out and said basically that Ethereum wants to move towards proof of stake long term? And if that's true, then what function does ProgPoW serve as like sort of an intermediary layer between straight proof of work, ProgPoW, and then proof of stake? Or what? Help us understand the point.
So originally, when ProgPoW came out in early 2018, it was meant as a gentle transition to proof of stake, because then they were going to go for Casper FFG. But ProgPow's role it's going to serve is in securing Ethereum 1.0. So most people don't realize that Ethereum is actually going to be two chains. They just think Ethereum will be one. It will be a split between S1.0 and S2.0. S2.0 will be the proof of stake version. S1.0 will be the proof of work version. And it's in our best interest to ensure that the 1.0 chain is decentralized and widely distributed on commodity hardware. And it's very hard to dominate that chain at scale, because if you can dominate the proof of work chain, you can manipulate the proof of stake chain. And both these chains work in harmony. Eventually, the proof of work chain will die down over a course of 2 to 3 years. Some are saying 4 in the S2.0 team. But either way, eventually all of the applications and all of the smart contracts and everything will have migrated over to S2.0, and there'll be a gentle phase out of the proof of work chain.
So to be clear, you're talking about a hard fork essentially, where there will be essentially 2 tokens. So just like Ethereum Classic split from Ethereum, you're talking about essentially another Ethereum chain where there will be a different type of token, yeah?
So as far as I understand it, they'll be one-to-one backed with each other, but I haven't researched into that. But this is on the Ethereum roadmap to have the 2 chains.
Will you be able to switch back and forth between the 2?
Yeah, I think it's more accurate to think of it more like a side chain. So it's 2.0, because remember, when you're staking, you're not actually mining for tokens.
Right.
So it will be more like a side chain. I think that's a better way to think about it.
So help me to understand. ProgPoW, has it actually been adopted onto the Ethereum roadmap, or? So
depending on who you talk to, it has or it hasn't been.
Okay.
The core devs. So when ProgPoW first came out, everyone wanted it. Everyone loved it. Then slowly over the course of a year and a half, miners got really disenfranchised. They got very frustrated with being told they were useless, they were profit chasers, and nobody wanted them on the network. So slowly their eagerness and their willing to contribute to Ethereum in any way, shape, or form has dwindled. That being said, ProgPoW is officially scheduled for adoption in the roadmap. That was announced by Hudson. They're going forward with an audit first. The audit is because a bunch of people believe I'm I'm some boogeyman and I put backdoors in the code, which is cool. I mean, I'm glad people think I'm so smart, but and also a general test of ASIC. Talking to a lot of ASIC manufacturers and figuring out, could you build an ASIC for this, and if so, at what efficiency? However, that concerns me a little bit because most ASIC manufacturers are incentivized to lie. Lindsay has the biggest reason to lie to people, because if ProgPow, once it officially forks, there goes all of their capex investment in NRE and ASIC development. It would be devastating to them. So ASIC manufacturers often like to not necessarily lie, but over exaggerate their capabilities. We see this all the time in SHA-2560 world. A manufacturer will say they have an insane terahash per watt, and then the final machine actually underperforms quite a lot.
Mm-hmm.
So Istanbul is scheduled for next month, right? The Ethereum network upgrade. Is that still accurate?
I'm not sure actually on the Istanbul forks, but I can say that it will probably be its own separate fork. Generally, when you're doing enterprise software, you want to loop major, you want to isolate major features, so that if there's a bug in Istanbul, people won't blame ProgPow and vice versa.
Okay. So potentially ProgPow after Istanbul and not necessarily
ProgPow. Yes, they've already announced that ProgPow will be its own separate fork.
Okay. Can we have a fork called KungPow?
That would be awesome. I like that.
Yeah, and that maybe chicken in there. But okay,
you heard it here first, guys.
Yeah,
I like that. That's going to be my CPU. POW.
Tom S is one of the attendees here on this webinar. He asks a question related to all that. I'll just read part of it. Do you have any estimates of how ProgPow energy consumption compares versus traditional Dagger Hashimoto /hash?
Yep.
Yes.
So we do actually. This is on our. So for most people that aren't aware, ProgPow has a very healthy documentation that lives in the weirdest place of all, our medium. So we actually walked through the energy cost on our medium compared to Dagger Hashimoto, and it's about it's about 20% more. Though some miners have optimized it to be about 15% more. And I believe I can drop the link in there, right?
Yep.
Somehow, let me pull this up.
Should be able to drop it into the chat.
Yes, just give me 2 moments to.
And then while Kristy's getting that, JP, should we just get right into Q&A, or do we want to officially wrap up the official part of the webinar?
Yeah, well, let's include the Q&A in it, and then we can wrap up and at least end the broadcast.
Okay, great.
So I should be able to reply here, right? Type answer. There we go. There. I think I answered him. So
sweet.
All right.
I'll tackle the next one. So Chad Leposki asks, what is the next generation beyond 7 nanometer, and what is a realistic timeline for its development?
Yep. So that one's 5 nanometer for TSMC, and I believe Global Foundries is pursuing it. And then Samsung will either go to 7 nanometer ELVP or LVP, I think it is, and then progress to 5 nanometer. We're going to see 5 nanometer fully matured probably in 3 to 4 years.
And is that going to be the end of the road for silicon?
No. We have the opportunity to scale down, but at some point it doesn't make that much sense, because as you have more and more complexity, it requires much more specialization and much more development costs, and the wafer costs get higher as well. So I think we'll see ASICs stick around at 7 nanometer or 8 nanometer for quite a long time. I don't believe ASICs will ever go to 5 nanometer in the next 7 to 8 years. It's just not feasible.
ASIC for mining?
Yeah, correct. 5 nanometer will be more for things like your phones, your smartwatch, very small devices.
Scott, do you know how to pick up the next one? If you just click open QA.
Answer live. Okay, so I see Michael S. He's asking, what in your opinion are the market shares for the main ASIC manufacturers like Bitmain, Innosilicon, Canon, and MicroBT?
So Bitmain has about 40% market share. Canon has around 30%, so it's quite healthy there. And the rest is, and we're just talking about Bitcoin right now as well, because if we go into other coins, it's a whole different market share. MicroBT is taking the lead advantage very slowly between Inno and MicroBT. So MicroBT has around just around 7 to 8%, and they're working their way upwards very steadily.
And I guess that's also in the public side, because they might be thinking, when a product is launched on the Bitmain website or on the Canon website, that's what a lot of people see and think about. But there's a lot going on behind the scenes that a lot of these larger companies.
It's minor. And Innosilicon wasn't really a household name from the beginning. They only really came to light with the Zcash machines in 2016, 2017.
What about like Bitfury? Where would they fit into all
Bitfury sells chips, and a lot of those chips get reused by other manufacturers. I'm actually not familiar with their market share. I know they're very popular for the there's another kind of miner that I think it's called Bitfly or Bitfly. Those use Bitfury chips. You're right, I forgot about Bitfury. So Bitfury is quite big, especially in the EU. That's really their domain and where they dominate. Bitfury has done most of their sales, however, for either private investors or for their own operations. Bitfury does a ton on their own private operations.
Right. Cool. So Michael Saviskin asks how much,
MPW.
Yeah, MPW. How much does bypassing MPW, how much of that is a cause for quality problems? If I say that correctly.
Yep. So quite a lot, actually. It's not, I wouldn't say it's a cause for quality problems. I'd say it's a cause for underperforming chips. So if you do not do an MPW, you're taking a huge risk. Like I said, it's not a big risk if you're above 10 nanometer, but once you go below, you need to do an MPW. And there you're not able to accurately trust the simulations that you're getting from Cadence or Synopsys. So you have to do an MPW to be able to see, hey, what is my performance actually going to be?
Okay.
Chad Lepowski asks, given the difficulty even a company like Intel is having developing efficient SHA-256 ASICs, how are we going to get a realistic competitive marketplace? And are we stuck with Bitmain being the 800-pound gorilla for the next 5 years?
Wait and see what I'm working on and what I announce in 2 months.
Oh boy.
I would say that there are some companies like Squire Mining that have popped up into the ecosystem, and I know of a few others as well. They're all US-based companies, and they're all looking to go into SHA-256D design. Do I think they will compete with Bitmain? No. But do I think that the fact that they're willing to look and invest into this space is good? Yes. I think Bitmain's going to be the gorilla for at least another year. But if a platform or a marketplace becomes available that forces them to comply with standardization, as we deem a public company should, forces them to comply and actually provide information that a public company would normally operate with, I think the market will accept them more readily. And I think that's what needs to happen. That's where the market needs to go.
Kristy, slight tangent on that or follow-up question. Can you ballpark the total startup capital costs to start a new ASIC manufacturing company?
Yeah, it's actually cheaper than most people would realize. It's for SHA-256D development, it's less than $850K right now. And that's like really, really handsome pay. And then that will cover all your NRE costs plus design costs. And then the actual wafer cost is going to be anywhere from, I would say for 1,000 machines, 2.5 to 3 million. So if you have $10 million raised, you can actually make a really competitive chip.
Really? And you can get to production with that chip?
Yes, provided you know what you're doing. There are companies that have raised $10 million, tried to do a SHA-256D ASIC and failed miserably because they had no idea what they were doing. So it's
that requires a lot of know-how and spending capital very efficiently, basically.
For SHA-256, yes. Now, if we take any other algorithm, let's take a very smaller algorithm like Equihash is a little hard.
What about the Grin algorithm? I can't. I'm not even going to try to pronounce it.
Kukatu,
I probably shouldn't have commented.
Kukatu, there's two, right? Yeah.
Kakamini.
Between Trump, Silicon, and Vorik, one of them will murder me for violating some NDA. But like, so mostly, let's take Monero. Monero is a good example I can talk about because I'm under no NDAs for Monero. So to design a very efficient Monero ASIC back when CNV8 was a thing, it would have cost you $175K in engineering costs, and your wafer cost would have been below your all-in machine cost for around 1,000 machines would have been below 2.5 million.
Okay, so actually cheaper once you move away from SHA-256 towards something like Monero.
SHA-256D is, I understand that it's actually a really simple algorithm, but it's simply because the amount of specialization you need to do to get any sort of competitive advantage over a GPU is on the analog design layer. So you really have to sit with a talented analog team and tune. Now, things like Monero are more digital logic, and it's enough to just have the optimized GPU and FPGA code and then go straight to silicon because there's no other ASICs you're competing with, right? So it's that first mover advantage.
Got it. Anonymous attendee asks, is the Bitmain S17 the GMO B3?
I do not understand how to answer that. Does it mean it's non-existent? I saw many of them in China. Is it expensive? Yes, it's incredibly expensive. They offered me a $25 discount per miner. I don't think Jihan liked me calling him out on some of his statements about ProgPow. So it's very expensive.
Okay, Volker Herman says, having a market share of about 40%, Bitmain has a huge influence when it comes to SHA-256 mining. What do you think about the financial problems Bitmain still has, and how would this affect the industry if it gets more serious? I guess that's assuming that Bitmain is having financial problems, and I don't know if that's substantiated or not. But
so I mean, we know that they laid off their team. That was very public. We know they closed down some of their operations. All of that was very public. It's not really an issue if they have that large market share, because it's equipment that's already sold. So if they go bankrupt, that's not a problem. I think we should be more concerned about the fact that that's just market share. That's what's sold into the market. That's not their mining share. What would suddenly happen if Bitmain controlled 60 or 70% of the network of Bitcoin mining, and then all of a sudden they turned off all those machines? A lot of chaos would be caused then, a lot of danger. It is unhealthy to ever have a monopoly in a market, and it is incredibly unhealthy to have a duopoly run by two private companies. When people like to say that the GPU ecosystem is a monopoly, actually it's a very healthy duopoly with companies that constantly keep each other on the toes. They're publicly regulated. We know how much market share each has, and they're forced to compete on the innovation and the IP piece rather than the price. So it is a concern. It's a big concern.
Okay. Dennis Daniloff asks, what do you think about AI ASIC chips? Will we see them one day?
We will, and we do see them all the time. Canon's new chip, Kendrite, is fantastic. I'm absolutely in love with it. I actually have, for our viewers, a unique sample of Canon's new board. So there's the little Kendrite chip here. So in Canon's new A10, this little chip, which has a cost of about $3.50 and a sales price of about $10, actually powers their entire mining rig. What I mean by that is traditionally you've had an FPGA do most of your control board work or some sort of ARM core. And so what Canon has done for their new boards is it's actually Kendrite. Kendrite does all of the firmware, runs CG Miner, has RISC-V in it as well, which I'm super excited to start using, and is possible to do your ASIC boost overt and covert all in that tiny little chip. There's enough room in there for a rhinoceros to roam around in. So I'm really impressed by their AI chips, and they're targeting the facial recognition market. InnoSilicon is diversifying into, they already have a very healthy business in memory PHY being sort of the memory, the physical connect to connect memory chips with the GPU card. Very healthy business there. They're diversifying into AI chips and building out their AI hardware. Bitmain's very competitive with Sophon. I got to see some of their newest generation Sophon products. I was quite impressed by there. So every step of the way, companies are diversifying into the AI field. And this is why an algorithm like ProgPow is so good, because it will increase that speed of innovation. We want more manufacturers in the AI space. We want more competition there. The other thing is that AI is very vast. When people say they're building an AI ASIC chip, you have to ask them, what are you actually doing with that chip? Are you just doing facial recognition? Are you doing TensorFlow? It's very hard to build an ASIC that's general purpose. We call those GPUs.
Awesome.
So William Tesney cites a source of the Bitmain blog talking about the hash rate disclosure. It says it's updated on April 10th, 2019. His question is, Bitmain states that the SHA-256 hash rate of all Bitmain-owned hardware is currently 2,072 petahash per second. Is this likely just their speculative mining or their cloud mining operations combined?
Oh, I like that they have their ethash up there as well. I'd like to contest them on their ethash. So here's the thing about this disclosure. That is technically only Bitmain-owned hardware. If you're a very smart company, you will make sure you have a ton of little subsidiaries that all own and operate their own mining farms, and none of it's tied to the main company. So part of that will be their own mining operations, and part of it will be for their own. So the part for their cloud mining farms will be under those specific companies. So Bitdeer is its own independent entity. Bitdeer would have its own company and its own hash rate associated with it. So this would be all for their own profit.
Okay. Last question. Chad Leposki asks, is Jihan staying or going?
Jihan's staying. I made sure to, so there's a new CEO. His name is, oh God, I can't pronounce it. I'll butcher it, but Hachio, I think is his new name. He's pretty awesome. And Jihan has become a director. He will be CEO and founder of Matrix, a company that will do investments and really focus on the exchange piece for cryptocurrencies. And McCree Zhang continues to lead out the AI division for Bitmain. But the new CEO is in place, and he's a wonderful gentleman. He's also an engineer, so we got to geek out a little bit together.
Awesome. Well, I think we've gone way over time, but that's okay. This was a fascinating conversation with you, Kristy. we really appreciate you being here. Thank you so much for taking the time to join us. We'd love to have you back on at some point, maybe in May or whenever you make your announcement. Maybe you can make it here with the BCMA folks. And
I think we can definitely do that. It will be game changing and revolutionary. I can say that. I'm so excited.
Awesome.
Well,
Excellent.
thank you so much for having me, guys. I really appreciated it.
Thank you. Let me go ahead and turn this off.